Chapter 4, Section 3. In this chapter, we will learn about global maximums and global minimums. A global maximum is the absolute highest point on the graph, and a global minimum is the absolute lowest point on a graph. It's important to distinguish between global maximums and minimums from local maximums and minimums. Sometimes they overlap, but sometimes they are different. Let's look at a graph to see what I mean. If you look at this picture, let's start by looking at the local maxes and local mins. We're going to have a local minimum whenever we're at the bottom of a cup. So you can see that here there's 2. And a local maximum is going to occur whenever you're at the top of a hill. So here on this graph there's 1 right in the middle. A global maximum is going to be the absolute highest point on the graph. So looking at this picture, you can see that the highest point is the rightmost endpoint. So that's going to be our global max, which is also a local max. Now, our local min is going to be the absolute lowest point on the graph. So here you can see that it's the local min and global min that's right near the right side of the graph. The difference between a global max and a global min and a local min and a local max is that with local points you can have lots of them. There might be 5, there might be 10, there might be 20, and in general with global maxes and global mins there's only one of each, although on some rare occurrences there are 2. But like I said, local there can be many, whereas global there's generally only one. So how do we find these? Well, to find a global max or a min, you saw on the last picture that sometimes it's going to happen at a critical point, right at the bottom of a cup or the top of a hill, or at an endpoint. So in order to find these, what we want to do is we want to test the critical points and the endpoints to see which one is the highest and which one is the lowest on the graph. So how do we do that? Well, in general, you'll be given a function and you'll be given endpoints for that function. So here, let's look at the example that f of x equals x squared minus 4x plus 7, and we want to find the global max and min for x between 0 and 3. When you're given bounds like that, those are your endpoints because we're only looking at this graph between those points. So the first thing we want to do is find the critical points. To find the critical points, again we're going to take the first derivative and set it equal to 0. So our first derivative is going to be 2x minus 4. We set that equal to 0 and we want to solve for x. We add 4 to both sides and divide by 2, giving us x equals 2. Once we have our critical point, we want to test our critical point and our endpoints. Our endpoints are 0 and 3. So we make a list of our critical points and our endpoints as I've done below. X equals 0, x equals 2, and x equals 3 are the points we want to test. We then take each of those x values and plug it into the original function to get the corresponding y value. That will tell us exactly how high up or how far down each point is. So when you plug 0 into the original function, you get y equals 7. When you plug 2 into the original function, you get y equals 3. And when you plug 3 into the original function, you get y equals 4. You want to look at just the y values when you're classifying these. So you look for the largest y value on the y-axis. So here, it's going to be y equals 7. The largest y value is going to be your global maximum. Then your smallest y value, or the one furthest down on the y-axis, will be your global minimum. Sometimes you'll be asked to find a global maximum or minimum without being given any endpoints. What this means is that there's only one critical point, and that critical point automatically becomes the global max or global min because it's the highest or lowest point on the graph. So let's look at the function f of x equals x e to the negative 0.2x. Here we want to find a global maximum. You'll see that there's no endpoints, so we assume that there's going to be only one critical point. So let's check. To find a critical point, we want to know when the first derivative equals 0. So you have to do a product rule here to get the derivative. I've done it out, and the result is e to the negative 0.2x minus 0.2x e to the negative 0.2x equals 0. Now, again, if you have a function equals 0 that has e's in it, you want to factor out the e term. So when you factor out the e term, you get e to the negative 0.2x times 1 minus 0.2x equals 0. Again, since e will never be 0, we know that 1 minus 0.2x will have to be 0. Solving for x, we get that x equals 5. So indeed, we know that there's only one critical point. So once you know there's one critical point, you just want to make sure that it's actually a maximum. A couple things you can do. You can do the first derivative test, the second derivative test, or you can simply graph it on your calculator just to make sure that it is indeed a maximum. In this instance, this will be our global maximum because it's the only maximum. So these are the two cases you'll have to deal with. So go ahead and try some of the homework from Chapter 4, Section 3.